Question 5, part D, it says, under what conditions is this function going to be bijective? So I have to talk about, it says, for what domain and what codomain does this function meet this criteria? Now, bijective means it's injective and surjective. So if it's injective, it has to meet the horizontal line test, which it doesn't because of this part here. Okay, if I removed this part here, then I wouldn't have y values that have two x values. So I'm going to have to say, right, my domain, or my x values, my inputs, I need to write as x greater than or equal to 1 all over root e, where x is an element of R. Okay, that's one way to write it. Now, the reason I'm talking about this point here is because it's my minimum turning point that I just found out. So I know that once it goes back past here, it's going to have more than a y value that has more than one x value. So that's why I'm talking about this point here. And another way to write that could be, you can include the 1 all over root e and all the way up to infinity, but you don't include infinity where x is an element of R. So that's talking about the domain. If I want to talk about that, so that's it being injective now, it meets the horizontal line test. If I want it to be surjective, I need to have every y value is being used. And if I look here, all these y values are not being used. So my codomain, I'm going to say is where y is greater than or equal to minus 1 all over 2e. Y is an element of R. Because if I say that these aren't possibly allowed to be part of my codomain, then every other y value is busy here. It has an x value linked to it all the way across. So now my codomain is the same as my range, therefore it's surjective, and then now I have them both injective and surjective, so it's bijective. Could also write this as minus 1 over 2e, comma, where x is an element of R again. That's it.